Hi, class. Today we will learn about how to write a Matlab program to design an FRR band pass filter. Okay, first thing, we have the length of the filter is 51. So we have to set our n equals to 51. Okay, so now load your database from this website, okay, which is the EEG signal. And this EEG signal is correlate the genetic predispositions of alcoholism. This data contain measurement from 64 electrodes that placed on our EEG scarf sampled at the 250 Hz. So now we have to download our EEG signal for our subject 1 is the alcoholic and also the subject 1, same subject for normal. Okay, consider these 5 different frequency bands, which means it's delta from 0 to 4 Hz, theta from 4 to 8 Hz, alpha from 8 to 16 Hz, and beta from 16 to 32 Hz, and gamma from 32 to 64 Hz. And have to compute the tabulate, the mean, minimum, maximum, average, standard deviation, variance, energy, and power, and filter the signal of normal and alcoholic subject. Okay, now we start our exercise. First, we have to copy this link and we search in our Google. Control V, enter. Okay, this is all the data that we got. So in order for you to know which data should we take, we erase this word and we have the database. So we go to our EEG data, the description. So we open. So this is a EEG based data. So this is a multiple electrode time series for our EEG recording for the control alcoholic subject. Okay, this data is arise from the EEG correlated genetics for the electronic alcoholism. So we special thanks to the owner, Mr. Harry, okay, from the State University of New York's Health Center for his source, and also to the donor. And this is the data that we examined at EEG for the alcoholism. Okay, this data is 64 electrodes placed on the subject's scarf and 250 Hz, 3.9 millisecond epoch for 1 second. Okay. So they have two groups of the subject, alcoholic and the control. So post them in a single S1 or S2 and S2, S1 and S2 for two simulate. Okay, so here show the example plot of your control and alcoholic. So you can click inside. This is a control. Okay, this is the alcoholic. Okay, this one is the channel, respect to time, and also the electrode. Voltage, channel, and also time. Okay, so first we have 122 subjects. So each subject have 120 trials. Okay, shown at below. Okay, from here we have to take our two subject study, two subject, A alcoholic and the control C2 co-alcoholic. Okay, so alcoholic, which means your subject has an A, so control group you have a C in your sample. So now we go to our sample and have a look. This is the format of the sample that we look in. Okay. Okay. Now we go back to our data. Okay, this is our data. So we take one subject. So we take subject number 364. So this one is A, which means our alcoholic. So we have 364, the first one, and this one is C, is the control. Okay, for the 364. Then we right click. We click save. Okay, now we save it in our file. Save. And then We save for our control. Save. Okay, save. Then we go to our file location. Okay, show in folder. So this is our file locations. We have these two graph. Then we extract it in a we extract the file. Okay, after we extract, okay, we know this is the location of our file. Okay, so inside here we have total up to 88 items. Okay, so for the first one, we just right click, okay, extract. Okay, and this is the file. Okay, this is the location that we want. So from here, we copy the address, and now we go to Matlab. So this is the Matlab code. So we paste our address in here. So enter. Okay. Okay, this is our address. Okay, here. Okay. Never mind. Oh, sorry. Okay, enter. So we can see this is our current folder location. Okay, this is the signal that we want. So first, we right click. So import data. So when we import, it comes on this one. So we don't want this form of data because this form of data is then separate out the channel. So we select to space. Okay, so we can see this is 1, 2, 3, 4. So this is the place that we want. Okay, this one is the channel. So we have channel 1 until okay, all this is the location signal that we want. Okay, so this one is the signal. So this is the channel. Okay, so so it's FP1. So what is FP1? So if you refer your ECG, so this one is our ECG signal that we can record, okay, from our plan. So this one is FP1, which means channel at the top of our head. So it's in this location. We would like to take the channel, the electrode channel from this location. So total have the whole thing is 64 channel. Okay, then we go back to our Matlab. Okay, so after that, you have to select table, become metric form. Okay, so that now this is in metric form, then we select, we just interested in this column. Then select this column, import selection. Okay, done. So it based out is imported at this following file. Okay, so we can go in, see, yeah, this is the following file that imported from our data. So from this data, okay, we can write a coding. Okay, we let A into this data set. Okay, then for example, we want to plot delta. So B, we just put any name, B1 equals to FIR filter. Okay, N equals to 51. Okay, then it's the low pass filter because this one delta is from, if you heard the question, delta is from 0 until 4 hertz, which means it's a low pass filter. Okay, then we put in convolution. Okay, then we plot figure 1 and we subplot. Then title is a normal. Okay, this one is not a normal. This one is the signal one is alcoholic. So we can put it is alcoholic. Okay, delta. Okay, then we calculate for our mean, minimum, maximum, standard deviation, variance, energy, delta for power. And then we run this code. Okay, this is the signal for the delta. I'll call it signal. Okay, so this is our, later on you have to label your x-axis and your y-axis. And then inside your command window, we have the answer of minimum, our mean, minimum, maximum, standard deviation, variance, energy, and power. So all these are the time series features that extracted from this signal. These are the features that we extracted from the signal. So from this signal, we get all the features. Okay, so you can try it for the others. Thank you. So remember to subscribe my channel, okay, and like and share. Bye. I hope you enjoy this video.